Thank you all for joining. Good afternoon, everyone. So my name is Bryan Menendez. For those of you that haven't met me before, I help handle RIEGL USA's public safety and forensics clientele. I have some years of experience working with all of the RIEGL sensors, but I focus primarily on forensics now. This webinar is going to be about 30 minutes long. I'm going to do an overview of all of RIEGL's forensic toolkit. That includes all of our hardware, all of our software, particularly RIEGL, which is our forensic software, and everything from there on. I'm going to go ahead and start. First things first, I want to go over the agenda. It's a pretty short agenda today. First, I'm going to talk about the VZ600i and the VZ400i. There are two main tripod-based forensic tools, hardware tools for accident reconstructionists. I'm going to go through and highlight data collection with those scanners, and then also some other hardware advantages that exist with the RIEGL technology. I'm going to move on to some data processing techniques and some unique things about our software that make it really unique, really special, and why RIEGL is going to be or will be an excellent tool for accident reconstructionists. Then I'm going to highlight a particular project from IPTM 2024, the conference that just passed this year. I'm going to show you a video highlighting a particular accident or simulated accident from that conference. And then I'm going to wrap up with two customer success stories from two of our existing forensic users at RIEGL. And then finally, we'll finish up with some Q&A. So very first thing, I want to introduce you guys to RIEGL's newest tripod-based scanner. It's going to be the VZ600i. So it's a very compact, very versatile, and very, very fast scanner. Just so you can get to know the hardware around it. So the front side of the scanner, you have the beam exit window on the front. And below that, you have three internal cameras. Each one of them is taking 12 megapixel images. And then on the other side of the sensor, you have the touchscreen. The touchscreen is used to set up the scanner, hit start on scan positions, really do everything, do all of the data acquisition. You don't need a separate phone or some other separate tablet to get this to work. Moving below that, we have you can see it there, it's a green button. It's a button that we can use to turn on the scanner, but also start scan positions. That button actually plays a pretty important role for customers that are in cold environments or they have gloves on or something like that, and using a touchscreen doesn't really work. So we have that button there so you can start and stop the scans without having to take your gloves on and off every time you have to start and stop a scan position. On the lower half of the scanner, you have two butterfly doors that open up, and you can fit two batteries inside of it for a total of 3 hours of scan time. And then below that, we've got a quick release mounting adapter that quickly snaps on and off the tripod, and also has a separate second purpose as a stand for the 600i, and I'll show you more about that in a later slide. So a couple of notes about the scanner. So like I said before, it's really, really quick. So it'll do one scan position at 25 seconds at 6 millimeter point spacing. We benchmark all of these guys at 6 mil. The scanner is also in those 25 seconds collecting high resolution images with the internal cameras. So one scan by default, the default settings, you're going to get 25 seconds of scan, 6 millimeter resolution, and then the cameras are going to trigger at the same time. Next key feature with the 600i is onboard data registration in real time. I'm going to talk more about what that is later if you don't, but it's a very important key feature on the scanner that saves our users a ton of time, especially out on the field and back at their desk. Next is going to be its IP rating. So the scanner is IP64, means it's splash proof and dust proof. The advantage in that is you never know when you're going to have to use it. It could be raining, could be in a dusty environment. The scanner can hold up to it well. It's very robust. You can use it in the rain. You can use it in the desert, particulates in the air. It doesn't really matter. With all that, you also get nearly 3,300 feet of maximum range on this sensor. For all of our accident reconstructionists and forensic users, we include 2 years of system warranty with every TLS sensor, and we also back the product for its lifetime. So you get full product support the entire time you have the sensor at no cost. Then just to include a real world metric here, most accidents from our forensic users currently, they scan them in about 10 minutes. Most 2-car accidents, they'll scan those in about 10 minutes. So the predecessor to the VZ600i is what's coming up next, which is the VZ400i. As you can see, it looks a lot different than the 600i. They have their similarities, they have their differences. This scanner was released back in 2015, and it is still very competitive on the market today. It still has the same touchscreen on the back that's very easy to use and makes operating the system quick and efficient. One of the key differences is this system has a full metal housing, so it's a little bit heavier than the 600i, and it's a little bit slower. So a 6mm resolution scan is going to take 45 seconds to do, but it still collects images at the same time. The scanner still has real-time onboard data registration. Fun fact about RIEGL, any of our sensors, any of our TLS sensors that end in an I, so VZ400i, VZ600i, they have that onboard registration feature built into them. As long as it's a TLS sensor, ends with an I. IP64 as well, so this scanner is still rainproof and still dustproof. A little bit less range at 2,600 feet of max range. The sensor still includes a 2-year system warranty, still includes lifetime product support, but that slightly slower scan speed. Our current 400i users are experience about 15 minutes per 2-car accident, give or take. So on the next slide, I really want to highlight the versatility and adaptability of the 600i. And in this slide, you can see the 3-point stand in action. So the first image that's on the bottom right-hand side is from IPTM. It's a simulated crash where they used that pickup truck to run into that mannequin. The mannequin ended up underneath the vehicle, so you needed to get data underneath the car. It's very useful to be able to put the scanner on the ground and collect data underneath the vehicle, as well as on top of the vehicle on the tripod. The 2 images that you see in the middle and on the left-hand side, they're from a project we did at Alcatraz in San Francisco. The first one in the middle is a spiral staircase, which was not convenient at all for a big tripod. So we instead just put the scanner on a step and kept moving it every couple of steps and scanned the whole thing that way. And we did this quite a lot because there's quite a few of those staircases in the prison. And then the image on the left is a cell from Alcatraz as well, but the area was just too cramped and too small to fit a tripod in there. So we just took a bucket, flipped it upside down, and put the scanner right on top of the bucket to scan that environment. So it really can be used anywhere. And then that smaller image that's on the top right-hand corner, I included that one just to show that the scanner doesn't have to be leveled to scan anything. It doesn't need to be set up straight. It has sensors inside of it that will automatically adjust for the tilt and correct it for you. The very next thing I want to talk to you guys about is acquisition with the scanner, collecting data. I really want to show you guys how you would do it, how you would collect data. So I've pre-recorded a video for you that I'm going to show, and then I'll just talk through the video. So all you have to do to start a scan position is hit start, and it goes, and this is a 25-second scan. This is on the 600i. After that, after this section of the video, it's going to cut to a video of me actually doing it, and you'll see that in a moment here. So I hit start here and then start scanning. The scanner will automatically know when you're done and when it's ready to be moved again. All you have to do is pick it up, put it down in the next spot you want it to go, and hit start again. So here you see me moving it with just one hand. It's very light. You just pop it down and hit start again. That's really the whole workflow for collecting with our system. This next section, I included it so you can see the fine scanning feature. So right on the data preview that the scanner gives you, it'll actually let you select an area where you want to collect a higher density array of points. You'll see that there, draw a square around that wallet and key, and the scanner will automatically turn to that area and do a higher resolution scan of it, and it'll incorporate that right into the larger point cloud. I know I said I was going to talk more about onboard registration, so I included a slide here for that. On the right-hand side, that's what the registration screen looks like on the scanner, and it just keeps a tally of which scan positions are registered to the project. What onboard registration means is as you're scanning, each subsequent scan is getting registered passively. There's two computers inside of the 600i. The first one is managing all the data being collected. The second one is taking that data and doing that registration. The image on the far left is the VZI project map. This is a great tool, especially when you're out on the field. So each circular blue icon is a scan position. The purple icon is the latest one or the most recent scan position registered. But nevertheless, it shows you the top-down view of the project, so you can get a good idea of what you've scanned so far, what you haven't scanned, areas you need to go to, and it gives you a good idea of your shadows, anything you might be missing. That's a great tool to use. Any device that has the capability of going on the internet and connecting to something over Wi-Fi is going to be able to see that project map, whether it's your phone or a tablet or a laptop. You can just simply connect to the scanner and go to that IP address 10.0.2.1 and it'll pull up that map right on there. So that's pretty much all the stuff that's built into the scanner that has to do with the hardware. I'm going to move forward to RIEGL, which is RIEGL's in-house developed software for public safety and forensics. So RIEGL is the only software that that you will need to process the TLS data. You can do everything in there. There's no other connecting pieces. The software is regularly maintained and updated by RIEGL as well. There's a lot of tools in there as far as measurements, arc measurements, data cleanup filters, and a lot more. And we'll get into that stuff in a couple of slides, but I did want to talk about the software here first a little bit. I included that image on the bottom there to show a general workflow of how we're going to process data in RIEGL. The thing about that one as well is that middle step for registration can actually be skipped. Again, if you're doing the onboard registration that's on the scanner, you can skip that step entirely. So, like I said earlier, we're going to break down RIEGL a little bit more. I want to talk about the simple step-by-step workflow first, which you see on the right-hand side. That's the one-touch processing wizard. It's just a list of tasks that run automatically. That's all that is. So you check off specific tasks that you want to run, and then you hit start, and the software will go through in sequential order and run them one at a time. The user can't really make mistakes here. It's very simple to use. The software will export all of the major point cloud standard formats, E57s, LASs, LAZs, and many more. There's also the PTS files and all those AutoCAD stuff. Then there's also diagrams that you can export directly from the software. The diagrams are cool because you can export them in JPEGs, you can export them in PNGs, you can export them as PDFs as well. My personal favorite is to do diagram exports as PDFs, specifically because they're exported to scale. The actual scale is embedded into the document, and you can open the PDF document in Adobe software, and Adobe software actually has tools within it to measure off of the PDF. So you can, whoever you send a simple PDF to, you can actually make pretty accurate measurements just off of that. Moving back to the image on the top right, you may have noticed I sort of drew 3 red boxes around some specific tasks that I'm going to go ahead and outline for you in the next couple of slides. So the first one is registration. Before I start talking about registration, I do want to mention that this step is entirely skippable with our I-Series instruments. All of the I-Series instruments have that onboard registration feature and allows you to completely skip this step, but I did want to show you how it works with the RIEGL software, show you what's going on. So this first image that you see is an image of a crash from IPTM this past year. As you can see, it is not registered at all. All the scan positions are in the middle. They're twisted and turned out of order, and that point cloud is completely unusable. In RIEGL, there's a tool called automatic registration too. It works pretty simple. It's very simple in how it works. You start it. It goes through your data in numerical order. So it starts on scan position 1 and then ends on the last scan position. In this example, there's only 8 scans, so just 8 scan positions that it goes through. It'll look through the scan position, find common features, overlap, and things like that. in order to stitch the scan positions together. So here's a quick video of automatic registration 2 in action. Every time it turns red, that's overlap that it found between other scan positions. I want to take this time to talk about the sort of adjustment that we're doing here. This is a cloud-to-cloud registration, so we're not using targets, we're not using spears, we're not using anything like that we had to pre-set up on the field to scan. We literally just took the scanner out of the box, turned it on, slapped it on a tripod, and started scanning. As you're going through, it's going to go ahead and passively look through overlapping features and putting those scan positions together. The tool is also using some other information like GPS data and IMU data to stitch these scan positions together, but most of it is going to be off of the overlapping cloud-to-cloud registration. And once that tool is done, you end up with a fully registered point cloud that is now can be used to do some sort of investigation, do your measurements. This is more of a deliverable state now. The next big tool that's in RIEGL is going to be the moving objects filter. One of the most critical things to being able to produce a deliverable point cloud is going to be how well you can clean it. And you're always going to have people who get in your scans. You're always going to have people that walk in front of it. They don't know what a LiDAR sensor is. They're not familiar with it, and they get in front of your data. So for the crashes I've been showing you, you always end up with something, or almost always end up with something like this, especially at IPTM where we had around 200 people probably out there watching these simulated crashes. They're all going to get in the scan data one way or another. Thankfully, RIEGL has an answer to that. It has a tool for that. So this tool is going to compare groups of scan positions and find objects that were moving inside of those scan positions by looking at adjacent ones. It's going to parse through all that data and automatically mark them for you, as you can see there. Once they're all marked, they don't get deleted. That's another huge feature in the software. We do not delete things. We don't want to delete things because it might cause problems in the future if someone asks you about certain data and why'd you delete that or why'd you delete this without being able to show them. So instead of deleting this data, we can actually just select it and move it to a cleanup folder in RIEGL. When you move it to a cleanup folder, you still keep a record of all of that information, but you still end up with a point cloud that doesn't have all of those people moving inside of it. The next tool I want to talk about is RIPano in RIEGL. So before I start though, you may have noticed there's a little QR code in the bottom right corner. So if you scan that QR code, it's going to take you to the RIEGL website. The RIEGL website on there, it's got a RIPano that we are hosting. If you scan it, you can go on there and play with this tool as I'm talking about it, and you can get an idea of how it works. I will say the data that you're going to see on the RIPano isn't going to be the exact same data that I'm showing you. The data that's on the website is of a castle, but nevertheless, it's still the same tool and it works the same way. It's just a different data set. First things first, when you run the tool, you're going to get a file structure. It's going to produce a folder called RIPano. Inside of that folder, there's going to be 4 files. There's going to be an app data file, or an app file and a data file, and then there's going to be a RIPano for Mac and a RIPano for Windows. The only 2 that matter to the user are going to be the RIPano for Macs and the RIPano for Windows. All you have to do is double click on whichever one of those corresponds to the system you're using, whether or not that's Windows or whether or not that's Mac. In my case, I just double click on the RIPano for Windows application file and it opens up an image that looks like this, or a browser that looks like that. From there, it's a top-down view of the data with little markers showing you where each scan position was placed. The color of the marker indicates the height of that scan position. So those scan positions that you see in blue are blue because they were placed on the ground, and the scan positions you see in orange and yellow were placed on a tripod. The user can then pan around that view and check it out, look at it, and they can also click on individual scan positions, and when they click on an individual scan position icon, it shows them the view from that scan position's point of view. From that view, they can see the camera images it took, and they can look at the LiDAR data. On top of that, they can also make measurements and do side profile views, plan views, and things like that. So what issue does RIPano really solve? Well, it solves the issue of having to send a point cloud to someone that doesn't know how to work with point clouds. If you're sending this to someone who doesn't know how to work with LAS files, E57, LAZs, or any of that sort of thing, this is your answer. This is what you send them. All this is that folder. So my favorite way of sharing, my favorite way of sharing a RIPano is to export it, take that RIPano folder and stick it on a flash drive. Then all I do is I take that flash drive and I give it to whoever I'm trying to send the data to. All they have to do is put the flash drive in their computer, double click on whichever RIPano file pertains to their operating system, whether it's Mac or Windows. Let's say it's Windows, they double click on Windows and they immediately get this view and they have access to checking out all of the data. They don't have to install anything. They don't have to download anything. They don't have to do anything. I mean, it's really just that simple. So it's a great tool for those kind of situations. Now, moving on. So this is the project highlight that I wanted to talk about. I really like showing this video because it shows even more features in RISolve in a very quick way. So the video is going to start out with an actual recording of the accident at IPTM. After that, it's going to transition into the LiDAR data where you're going to see different view types. And after that, it's going to show you different measurements you can make in the software. Another cool thing is the video that I'm making, the fly-through part where you can see the LiDAR data, that is also done in RISolve, all self-contained within that software program. So let me go ahead and start it. And here you can see the pickup truck impacting the mannequin. And now we have the fly-through, and this was done completely in RISolve. So you can see here you have the grayscale view, and then it changes to a rainbow retroreflectance view that can help highlight evidence, and then it switches back to the true color camera view. You're just highlighting some evidence, a shopping cart that was hit. And then there you can see some different measurements that were taken in the software, as well as the arc measurement on the wheel. This is done with the 600i. The 600i outputs 2.2 million points per second. So you're really, really able to get good detail on the small objects. So here on the bottom left, you can see the mannequin sunglasses and the hat as well that's on the ground. And then the metric for this project, this entire project was scanned in just about 8 minutes with the 600i. So it's very impressive to me. So moving on to the next slide, I want to go ahead and talk about a few success stories that we have from some of our existing customers. Some of you know RIEGL USA is headquartered in Winter Garden. We're very, very proud to be able to work with our local agency, Winter Garden Police Department. We've trained them, we've supported them through their sort of picking up and using of the scanner, and they've found great success with it. They had some kind words to share, so I went ahead and put those on the screen. San Diego County has been a customer of RIEGL since 2014, I believe. So they've been users for about 10 years now, and they're very advanced users of the software and of the technology, and they love it. So again, they've donated some kind words here, and I went ahead and included those. But the technology from RIEGL really is second to none. Both these users that I've highlighted know that they can count on our support team right here in Winter Garden to support them in any sort of hardware or software questions that they may have. So since I'm on that topic, I want to go ahead and talk about our facility. We have the RIEGL USA building that you see there pictured. It's in Winter Garden, Florida. It's open from 8 a.m. to 5 p.m. That's where our support and service and sales staff all work. In that building, once the support people leave, they continue working, and support is available via phone and email from 8 a.m. to 8 p.m. at no charge for our customers. So they can always call, shoot an email, and get help within an hour or two. Service is also done here. service is in charge of doing calibrations and is capable of doing most repairs as well. This really helps to impact and shorten those turnaround times for recalibrations if they need to be done. So, and thank you all for listening. I went ahead and put my contact information on the screen there with my email address and my phone number. You guys are more than welcome to reach out to me for any questions you may have. But I also wanted to take a second to answer any questions that you may have now. I believe there's a questions section on the GoToWebinar where you can go ahead and send any questions in that you may have. Okay, so I had one question that was, what are the specifications for using RIEGL? So for computer specs. So, all right, let me first finish the first one. So what are the PC specs for RIEGL? The PC specs for RIEGL are pretty minimal. I believe you need only 16 gigabytes of RAM and an NVIDIA graphics card, and of course a CPU. So they're pretty minimal. It's not an incredibly intensive program. And then I have another question with how many licenses come with RIEGL for the scanner. The way RIEGL operates or uses license structure, we do it on a serial number basis. So it's one license per scanner, and that allows users to have, and you're allowed to have an unlimited amount of users. As long as the data is coming from your scanner, you can process it on a million different computers at the same time for all it matters. You get one license that covers the entire scanner. And another question was, can RIEGL be used to merge multiple projects together? Yes, like I said, the cloud-to-cloud registration works off of overlap. So as long as those two projects, whether they were captured on different days or something like that, you can merge those projects together just using automatic registration too. All right, well, thank you all for joining in and attending. If you signed up and registered for the webinar, you'll get a recording of it too in an email just in a couple of days once we get it prepared for you. But thank you all for joining and taking some time.